Today we're going to look at the M series. We've got the MP3, ME3, the MP4, ME4. You can see the voltage is lower and the current is lower on the MP4. This was originally configured for stepping motors, but then we found people said they wanted it for a little DC brush motor and a little brushless motor with incremental encoder and Halls. So we said okay, but again, this is like 24 to 48 volts, 3 amps continuous and 3 amps peak, so it's for little guys. There's no absolute encoders. It's kind of like a standard base model. It does have some plus feature capabilities like EtherCAT. However, the MP3 is more of a servo drive. You can see it goes up to 90 volts, so like a 80 volt power supply. 5 amps continuous, 10 amps peak for a small package size. Today we're going to look at the MP3, and the MP3 is a module with pins that plugs into a mounting board. The MP3 can of course do point-to-point moves, runs a CVM Indexer, runs a CPL, Copley programming language on the board. Can do PVT moves, can do CANopen or EtherCAT. We're going to talk about CANopen today. You can see there's various modes of command, plus or minus 10, pulse and direction, master slave, and this has a full range of absolute encoders from like the BIS-C to the NDAT. The module plugs into a mounting board, and this mounting board is the development kit, and you can see here's the MP3 and the development kit. This allows us to do prototyping. On the last page of the data sheet, of course, are all the accessory items. Maybe you get the module and a development kit and a connector kit and the serial cable kit. If we take a look on the web page for all documents for the M series, we can see the data sheet, some CAD drawings, and this is real interesting. This is the development kit reference design. If we download this, we can see the this is the dimension drawings. The development kit reference design contains the files used, the pads files used to make you make your own PCB. This has the full schematics and drawings for all the the pinouts and the connectors and stuff. You can see in this schematic that it shows all the connectors, all the jumpers, and even shows the MOSI and MESO circuit used. It's like a serial peripheral interface to shift in the switch position for node addressing, and to shift out the blinking of the LEDs. And so this is done like at the position loop update rate. So that's very interesting. So basically, going over what I've got set up here, we can see this is a harmonic drive. This has incremental encoder with Halls, and is configured as Axis A. I've got a Cyber motor here. It's like a little Maxon type of replacement with good cabling. This motor actually has a BIS-C absolute encoder on it. This is a stepping motor. It could be a DC brush with incremental encoder or an absolute encoder, but this is just a stepping motor with a feedback device on an actuator here. Today I'm going to use the USB to CAN adapter from Copley, and this is the adapter network kit. It comes with a terminator, an adapter for 9-pin to RJ45 connected into the input for CAN. There's an output for CAN to the next. I've got the node address set here to 1. I program the drive over the serial port. This is a USB to RJ11 adapter. I program the node address to use the switch. We've got some enable and disable switches here by default for axes A, B, and C. I got the motor power hooked up. I got a 48-volt power supply. Again, this is a servo drive. We could use a 75-volt or an 80-volt power supply. The feedback devices are connected, and we're ready to make a move here. Things have already been tuned up. So I'm running CME2 version 7.1, beta 40 or greater, and I'm connected to axes A. We can see on the scope any kind of move that we do. And today we're going to do multi-axis trajectory updates. So let's take a look at just making a basic move first, and we should see a single rev of motion on the harmonic drive motor here. So this is multiplying the gear ratio and the counts per rev, and we can see a profile move here. So when we hit start, I set the wrap on this, so you can see the profile velocity: accelerate, run, decelerate, stop. I've got S-curve trajectory configured here, and the position starts at 0 and then wraps. I set the wrap on this at the output. So this is the position after homing, goes to 0, and when it reaches 240,000, it actually rolls over to 0 because I set the wrap. But the ability to do multiple axes of coordinated motion, we may be familiar with the ASCII command line doing the T1 command. When I issue the T1 command, I can see the motor rotates one time. Just as a note, for a multi-axis drive, I can specify the A axes to make a single turn, or I can specify the B axes, and that's this motor here. We'll hit it again, and it makes a turn, or the C axes. We can also specify a multi-axis trajectory update, and we'll take a quick peek in the ASCII Programmer's Guide. So this is trajectory commands, the T commands. T0 is abort, T2 is home, T1 is initiate a move. And if we set bits 12, 13, and 14, it will apply to all three axes synchronously. So we can see here how to configure the parameter for that. So that's initiate a move, and bits 12, 13, and 14. So that's hex 7001. Here's the decimal equivalent. We're going to send a hex command 7001 to make a multi-axis trajectory update. So it's a T0x for hex 7001, and this is the multi-axis trajectory update, and we'll see all three axes move in accordance to their trajectory, which I previously configured here with the scope. But let's take a look at the move here and enter. So all three axes, this made an open, this made multiple revs, this made a single rev at the output. So that's the multi-axis trajectory update, and that is also, it's in the ASCII Programmer's Guide. I should also mention that there's a serial binary, and the trajectory commands, of course, are opcode 17, and we can see that we can apply to multiple axes a trajectory and multi-axis trajectory update. So you load the trajectory generator, you apply the trajectory update, and away you go. The next thing I'm going to talk about here is another method for doing moves, and that's using the CANopen. We, of course, have CMO, Copley Motion Objects, which is Windows, and CML, C++ library. And the way the CANopen does is it uses the position buffer in the drive, loads up 32 points, and does PVT polynomial cubic spline interpolation between those points. So you know the old cyclic synchronous, or updating the position loop every microsecond. So what I've done here is I've captured the velocity and position, and of course if you zoom in you can see the samples here. So these position and velocity points are used if you do a PVT move, but really you don't, if you did linear interpolation, you'd need a lot of points. But to do the polynomial cubic spline interpolation, you only need like 7 points. So you can see that at this position, your velocity is 0. At this position, your velocity is maybe 50 or 100 RPM. At this position, you got a much higher velocity. At this position, you hit the plateau. So this is how you can define the P for position, the V for velocity, and the T for time is the time to the next point. So the next point will come at a certain time, and that's how you do the PVT. There is a PV segment interpolation in the drive. It's based on the polynomial cubic spline interpolation of the points we give, and again, T is the time to the next point. Given the position and the velocity of the current point, the buffer is filled up and away you go. So this document talks about how to model polynomial path, and again, CMO and CML do normally just a straight line point-to-point move using the linkage command, but there is a circle example, so a formula generates the PVT points, loads up the buffer, and initiates the move. And so there's just several ways to make multiple axes of coordinated moves. I wanted to mention that the CVM Indexer can also do a multi-axis trajectory update. So you said axis A move, do not use trajectory update, load the B and the C, and then at some time issue the multi-axis trajectory update. This can also be done in CPL. It's broken up into further parts. But this is just showing that the trajectory generator can be loaded and the move can be initiated either with the T command or from the CVM Indexer, or even over serial binary. Okay, thanks for watching.